How do you see quantum mechanics that's different than your colleagues?
Okay, yes. So that's a very good question in this context, because I could say, if I analyze how you are analyzing a system, how could I ever come to a contradiction with me directly analyzing the system? That's actually a core point of the whole question, because you could say this shouldn't happen. And this brings in, let's say, another question of what do we actually do when we use quantum theory? And what we are doing is we always cut out the part of the world which we are actually describing with the theory. We are never describing the entire world. And this is necessarily so, because if we did describe the whole world, we would necessarily have to describe ourselves, how we are applying the theory. And this would lead to a cycle. Like if I describe the whole world, I necessarily describe myself. And this may somehow be possible, but at least within quantum theory, we don't have the tools to do that. Quantum theory doesn't tell us how to describe a system that is myself, in a sense. Because I would have to automatically describe the reasoning process. And so this leads to a terrible recursion that is just not dealt with in quantum theory. So I would say the minimal or the maximal part of the world we can describe is kind of everything without me. I cannot describe anything larger than that using quantum theory. Now, this is actually a statement some physicists would disagree with, because if you are a many-worlder or a Bohmian, you would say, we can actually take an outside viewpoint and describe everything. And in a sense, they are correct, because they would somehow assume they are outside. Because by saying we take an outside viewpoint, they kind of suggest there is another super observer or something outside who does all the calculations and everything, like a godlike being.
Mm-hmm.
And if you say, okay, physics can just be applied from kind of this God's perspective, that would be okay. But let's say, a very basic ingredient in the, let's say, approach I took is that at the end we want to have the minimal assumption that we as inhabitants of this world can do physics. And that not only God can do physics, which for me is a very natural assumption, but it's very disputed. So I have this assumption that I want to be able to do physics, but I'm myself part of the world. And if I make this assumption that physics should be done it should be possible for us to do physics, and not only for an external to the universe being, and it's not even clear what that means, because if you're a being, then you are again part of the universe. That leads to troubles. So the question I'm asking is really, can I do physics? And if I'm asking this question, I have to be kind of modest and say, I can describe everything except myself using the current theory. Maybe there is some future theory that allows us to do recursive reasoning, but current quantum theory doesn't even talk about that. It just assumes we are, like, the description itself, the physicist is kind of external. That's an implicit assumption in a sense, because otherwise you couldn't even write down the state or anything of the system, because the state will constantly change as you write it down and so on. So this now means that so if I describe everything except me in the world, and you also take a maximal perspective and describe everything except you, then we still have different perspectives, because you didn't describe yourself and I didn't describe myself, but I described you as a physical system and you described me. And this is the type of setup where we find the contradictions. So we find the contradiction in scenarios where there are agents who are not describing the same part of the world, and they cannot describe the same part because they are themselves part of the experiment. So one important ingredient to the experiment is that at some point there is a measurement done on one of the physicists who are taking part in the experiment. That's what I meant when I said before that this is a very special situation, a very non-daily life situation, that one of the physicists is kind of going to be measured by another physicist in a very strange basis, not just in the, let's say, a measurement would be, I just ask you a question, that's also a measurement, but I could do a very complicated measurement, like a Schrödinger cat type measurement. And if someone did such a measurement on you, then or he has to describe you as a quantum system. But if you are also a physicist taking part in the experiment, you will not be able to yourself describe that part of the experiment in a sense. And so by using such building blocks in this thought experiment, so measurements of agents, I make it impossible for the agents to describe everything. So each agent has kind of a restricted view. And the view is kind of just the view that we usually have in daily life. Like if you talk about the experiment of your friend, you will not describe the whole world. You just describe that one. And so you have a different perspective from, for example, from me, who decided to, let's say, to describe you as a physical system. And if you're now asked to have the same perspective as me, you would answer, no, this is not possible. I cannot describe myself. So in a sense, we are constructing a situation where it's inherently impossible for the agents to all have the same view because they are somehow themselves part of this whole experimental setup. Some operations are done on them and so on.
What is the minimum amount of observers required for this no-go theorem or whatever you want to call it?
That's a very good question, and unfortunately I don't have an answer. I would say certainly 3 are needed, but in the experiment we found we need actually 4, and I'm not sure I can reduce it to 3.
Okay, so is it important that my modeling of you has your modeling of me in it? Or is it enough that my modeling of you has my modeling of you monitoring person 3, monitoring person 4, but doesn't have to come back to me?
Yeah, so the way we try... this is also important. So it's, in a sense, we try to avoid exactly such recursions because then we would again be back in that situation. So the experiment is set up in a way that the individual, let's say, users of quantum theory are users that you could do without having to describe yourself. And it's not obvious that this works. So we had to play a long time with arranging these agents in such a way that it works.
Perfect. Okay.
And at the end it's, because there's often a criticism saying that, at the end I actually describe myself indirectly by describing the other agent. But actually, to sort out this criticism, we actually wrote the software together with one of my collaborators, Lydia Del Rio and Nuria Nurgalieva. We once kind of decided to write the software that actually implements the experiment. And if we would have such a recursion, we couldn't actually program it. So this software kind of proves we can describe it by not running into a loop. And it's actually even publicly available. We put this at some point on the archive, so if anyone is interested to play with the software. But this is a question that always came up, and so we try to kind of convince people that it works by having this kind of automatic reasoning, if you like. So the software allows you to specify what the agents need to describe, and then you see that the description is not running into a loop.
Okay.
There is, however, some loop going on, which we may talk about when you ask me about how I think we can resolve it. But it's not the kind of description. So it's not that, so just to be clear, if you in the experiment you would describe me, you don't need to describe me how I'm describing you. You could just describe me on maybe only parts that are not, or not only the parts of me that are not involved in describing you, for example.
Okay. Now, is it important that the state in your experiments that the other person measures is a definite state, or can I give my prediction of what you see as a probability distribution or amplitudes or just a wave function that hasn't been localized?
Yes. So we tried in this experiment to actually avoid talking about states when we phrase the final statement or the final claim. Of course, we talk about states in the analysis. And the reason is that there are very different views on what it means to say that we have this state. So there are people who think of the state, of course, as knowledge, and others who think of them as something real. And so the entire experiment is a bit like, you can maybe compare it to Bell's theorem, where one could say at the end, the Bell inequality doesn't talk about states. It just talks about correlations that you find and expectation values. And this is a bit similar in this thought experiment. So in the analysis, of course, we use quantum theory and have to that involves talking about states, or you can also take the Heisenberg picture and then you talk about operators, if you like. But at the end, the objects the agents are talking about are predictions about outcomes. So you could, the only, let's say, thing we need is to say that to realize the experiment, we have some initial state that is known to everyone. But because that's a state that is kind of known to everyone, the question of whether it's epistemic or ontic and all these questions don't arise, because it's then just assumed to be common knowledge, and then everything is the same. So it's as if you would say, let's start with a spin pointing in the up direction. Then we kind of know what that means operationally. So that's unproblematic. But as soon as I'm going to use state as knowledge, I'm entering kind of a terra that is a bit ambiguous, because people may have different views on what that is. So what we try to do is to say everything can at the end be phrased in terms of the predictions. So the agents have this initial state they know, and then they just calculate a prediction which is of the type, I have this probability that this outcome will occur. And this is not phrased as states. So we try to kind of not give importance to the meaning of states and therefore talk as little as possible about quantum states in this experiment.
People should know that I'll be placing the links to your work and the full articles in the description, and they'll also be on screen as well. Mm-hmm. So for the physicist who's not a quantum physicist, who maybe is just a relativist, or maybe they're a materials engineer or something like that, I want you to give an analogy that I'm forcing on you right now, which won't work because analogies tend to not work, but it can give a flavor. So chess is often used as a way of thinking of physics, and the pieces are like particles, and then they have rules and so forth. And then you're saying that many physicists like to say, okay, well, let's just take a look at the board. And you're saying you're taking the perspective of the player, which is the God's eye view, but in physics, everything is physics. It's as if everything is the board. So you can't jump out and take a player's view. Okay, firstly, that's your critique about God's eye views. Then what you're saying is, let's imagine you're a rook.
Okay,
you are
maybe
a rook.
If I may say something about that. So I wouldn't even phrase it as a criticism. I would say, even let's say someone believes there is an outside view and that this view makes sense, like the player's view, the chess player's view, I wouldn't object. I would say, okay, you can take this, have this opinion that there is this outside view, but there should at least also exist an inside view from the, let's say, chess or whatever. There are these different characters on the chessboard from the king's perspective, because the king is one of the parts of the world. But so I'm kind of asking that this inside perspective also exists, and I'm not necessarily excluding the exterior perspective. I think it's not necessary because we don't have this exterior perspective. But I think whatever your view is about whether this God's view exists, God's viewpoint exists or not, at least the inside viewpoint, our view, also exists. So I'm just against denying the existence of that. And I want, so my requirement on a physical theory is that it's usable by us, in a sense.
Okay,
so,
perfect.
And if it's also usable from the outside, that's fine. So I'm not trying to exclude that viewpoint. I would only object if someone says the inside viewpoint is not a legitimate viewpoint. Then I would say, okay, why are you physicists? You're part of the world. And so by denying that as a valid viewpoint, you basically say you're not a valid physicist.
Hi, everyone. Hope you're enjoying today's episode. If you're hungry for deeper dives into physics, AI, consciousness, philosophy, along with my personal reflections, you'll find it all on my Substack. Subscribers get first access to new episodes, new posts as well, behind-the-scenes insights, and the chance to be a part of a thriving community of like-minded pilgrimers. By joining, you'll directly be supporting my work and helping keep these conversations at the cutting edge. So click the link on screen here, hit subscribe, and let's keep pushing the boundaries of knowledge together. Thank you and enjoy the show. Just so you know, if you're listening, it's CurtJaimungal.org, CurtJaimungal.org.